How many of you are aware of National Instruments? Okay, so don't blame National Instruments as a company which is stopping you from lunch. So National Instruments, just for people who are new, before I get on to the presentation, is a company that works in the test and measurement area, and specifically when it comes to communication, we've been having a really long working association with a lot of researchers in academia and industry in being able to build some of the prototypes and see how those algorithms work. There's some really great work that's happening on putting together a test bed where people can bring all of their IPs and validate. In the past, there have been fragmented efforts, and we've been a part of those efforts. I'll take you through some of those and also bring up a few of the challenges that people have been facing, people have been able to overcome, and share with you the approach that we take to be able to address some of these things. So that's going to be my brief presentation. And 5G, there's a lot of things that have been spoken about it. You probably are a lot more aware of some of the use cases of 5G. One question I have for all of you, just to make it a little bit more interactive, can somebody tell me the sort of commonality that some of these companies that I'm going to name have? Uber, Airbnb, Wikipedia. Platform, that's absolutely right. What do you mean by the platform? Anything more specific that you can probably... They're aggregators, right? So just like how some of our earlier speakers spoke about, 5G is going to open up some really amazing business areas for a lot of us, right? And it is because of the great things that it can do, from being able to address the necessary communication speeds, the turnaround times in terms of how fast things can communicate back and forth and how reliably it can do that. So all of that is going to bring up some newer business models that we are going to see. And for these business models to be effective and to be able to take benefit of 5G, I think there is a very significant amount of test challenges that are going to be coming associated with it. Not just test challenges, even as you're trying to put these things together, you would want to understand the implications of some of the things that you change as you build these 5G standards and networks, as we spoke about earlier. So what I'm going to do in the next 20 minutes or so is take you through some of these challenges that we've been able to address jointly. And like I said, National Instruments is a company that enables customers to use technology to be able to prototype and build things faster. So I'll share with you some of our customer successes on how they've been able to use some of these technology to address certain challenges that could be associated with 5G. And then we will talk about testing in specific, because that's the next paradigm that it opens up. And I'll probably conclude with talking about how this platform does not stop with 5G and how such a platform can be expanded to use or build future standards as well. So, like we spoke about, there are multiple areas where 5G could be of tremendous use. Autonomous driving when it comes to vehicles, maybe some newer business areas when it comes to agriculture. Maybe there could be one day a security company without any security personnel. It could be an aggregator at some point in time. So those are different things that are possibilities. And what we will address in this presentation is about how do we make these standards or test these standards as we build it, and also when it gets to deployment, as Sir was talking about, making it affordable for the Indian economy. What are the things that we can look at from being able to provide some of those test challenges, the necessary answers. So I think this is sort of the evolution of any new technology that comes into the marketplace, and specifically for 5G, I think most of the research started about in the 2010 timeframe. Maybe even earlier, there were people who worked on some of these technologies, but from whatever we've seen, most of the significant work started there. As the research kind of has kind of gotten to a good shape. There is semicon vendors who are now, as a part of some of these standards that are being put out, they are starting to build some of those semiconductor, and some of the trials, like Satish mentioned, have been demonstrated. And then, of course, it's going to go into production. Now, as we go through these stages, I'll share NI's journey so far in this particular 5G area. NI started our lead user program in 2010, and we've been associated with pretty much each and every one of the academic institutions across the globe. The very fact that a lot of you have used some of the USRPs and some of the software-defined radios that NI makes to prototype some of your research work is a good testament to that. And then on top of that, we have been working with some of the newer players and the existing players for them to establish what they've been building. And the reason why we've been able to do that is because of the openness of our platform. We spoke about a lot of openness in the TSDSI session, and that's exactly what NI as a company also provides with the platforms that we make. Now, as a part of this research joint work that we've done with multiple different universities, we were able to overcome and demonstrate some really interesting technology and the necessary performances when it comes to these next generation communication systems. I'll start off and just take you through some of these. University of Bristol and London University, and these universities have been working on MIMO. With MIMO communication capabilities and bringing in some of the millimeter wave, they were able to demonstrate a very significant spectral efficiency in their facility. So from there, Intel has been working on, again, MIMO area. They've been able to demonstrate some Cloud RAN technologies along with massive MIMO, again based on NI's technology. There was an interesting discussion that Pamela Madam brought about, whereby it is very important for these players to understand some of the challenges associated with the Indian context. Maybe taking it to the last mile. There, it is important for people to understand some of the channel characteristics. Like you said, inside the house or inside the hut, how does it look like? So I think AT&T, when they were doing some of those trials for the US, used a 28 gigahertz channel sounder, which was completely built on this open platform, and they've been able to do that for the US. And from there, we've had some really good association with Nokia, who've been able to prototype some last mile communication to demonstrate some tremendous uplink and downlink speeds. So that's the first millimeter wave prototype where Nokia demonstrated a 14.5 Gbps link, and that was done again using the open hardware. Now, the idea behind doing or supporting all of these researchers for National Instruments is to be able to help scientists and engineers be able to bring up technology and be able to achieve what they want to achieve without having to worry about some of the fundamental things that have to be put together. So we call this, again, a platform on top of which customers can very quickly build and put together communication systems. We do that in the other areas as well, but specifically on communication, I think we've had some tremendous success with our customers. So here's a look at Facebook's Aries Testbed, which has a massive MIMO setup, and you could see inside, those are the USRPs that were connected to the massive MIMO setup, which help them demonstrate all of these high spectral efficiency data rates. And then followed by that, Bristol, again with Lund University, have been able to demonstrate a 146.4 bits per second per hertz spectral efficiency in their facility. So what I'll do is I'll run a video which shares more details about it, just to see how that facility had been established and how the whole thing went about. And I'll take you through the rest of the things as well. I hope the audio works, so I'll move to the video now.
the time we were doing, probably didn't quite realise what we'd achieved. And it's really only the day after we realised that was a record. It woke up a little bit of a hornet's nest.
Yeah, I think we were kind of pleasantly surprised that it worked as well as it did.
Yeah, we were all going to a pub and dancing the whole night. No, don't drink that. No, I think when we broke the record, it was quite important, as we showed that in a limited spectrum, we can actually deliver up to 20 times more data than we can do in current wireless system. And if you think about that, 5G is all about to increase the overall capacity by 1,000 times. This is already a great step and a great part.
The massive MIMO approach with its spatial multiplexing, which is given to us through the large number of antenna elements, really is a complete technology revolution. It's a disruptive technology.
For me, massive MIMO can give us orders of magnitude improvement without the need for additional bandwidth, and that's critical.
What we have here in the setup is 64 USRP radios, each with 2 RF chains, so that's 128 elements.
So there's a significant amount of hardware that has to work simultaneously. It all has to be synchronized, and we have to eventually bring all the data from all the radios together in one place and centrally signal process it.
So with the NI MIMO prototyping system, we were able to alleviate some of the pain of this development through an integrated software and hardware platform that NI provide. So we could actually simplify a lot of the base layer of connecting the things together and getting data flowing, which typically there would be a lot of legwork just to get that happening. So we could do this, and then we could focus on actually implementing the functionality required for the system on top of it.
I don't think many people really worry about how their mobile device is connected to a network. What they want it to do is work. Massive MIMO will make it work exceedingly fast.
A real drive in the race is because we're just running out of bandwidth in 4G. Customers are demanding more, and the operators are struggling to be able to deliver it. And I think whoever gets there first is going to open up, huge societal and economical benefits.
I think that's a good example of developed economy problem. And I know there is a lot of work that's going on here in India to make the spectrum efficient as well. Not just efficient, along with that, bring down the cost of the product that's going to be able to do that. This is a good example from KU Leuven, where they've been able to build a full duplex communication system with a USRP again. And I know there is work happening in India. Professor Ganti and his team in IIT Chennai are also working on it. And I think these are platforms that can really help accelerate that pace of development of some of these really interesting challenges that we have to be able to address in the next coming times. Here is another example of Inatel trying to understand a situation in Brazil on how the spectrum is and how they can increase some of the data throughput by bringing in some newer coding schemes. And there again, with some of the technology that we've put together, one of the unique things about this open platform is you can bring in different algorithms and really quickly change and see how it operates on the physical world. You don't have to necessarily stop with simulation. If you have a simulation already running, you just have to take that and be able to put it on some of these software-defined radios, which can help you establish the physical implementation of the same thing, and you can see how the whole thing works. So that's I can get into the details, but for the lack of time, I'm going to run again. This was one of the first real-time implementations of spectrally efficient FDM systems, and they've been able to see some significant bandwidth improvements for BPSK and QPSK. I'm sharing all of this because across all of these different key technology elements, there are multiple researchers across the globe who've been able to publish over 200 IPs and a lot more papers, which can, add a significant amount of value to what the 5G standard is going to be. Now, as we started moving into the next stage, there have been instances where we've been able to collaborate with some of the different players in the marketplace to see how we can help them test it and also be able to establish some significant test beds which can do some of these validations. So this is NI's platform that we talk about. There are multiple different types of software-defined radio which can operate with LabVIEW, C, .m files, or GNU radio, name it, and you could potentially run them on all of these hardware. And there are also variants that can bring in the higher level aspects or the higher level networks, not limiting yourself with the physical layer. You can go all the way up the layers and be able to deploy all of those things as well. So you see the RADs and the wireless networks. So if you have a network stack tree, you could easily deploy it on top of it and have your network simulations also be done on these systems. One of the interesting projects that we worked on, this was quite interesting from the whole company's perspective. DARPA, which is the defense wing of the United States, they've set up a challenge. It's called Colosseum. It is to help people compete in the given radio network to be able to effectively communicate from one end to the other through multiple different types of channels that are there in between. And they wanted to set up something which can simulate a very, very dense city which could have multiple different types of communication going on at the same time, and make sure there is a collaborative optimization that happens, which is sort of very key, because as we move forward in this domain of 5G and beyond, that's going to be a key element which comes in place, being able to collaborate and still ensure that the message goes through. So you have the transmitters, multiple transmitters and multiple receivers, and in the middle is the channel. And what NI's platform helped them build is each of them could build their own transmitters, their own receivers, and the complete channel was implemented again using the software-defined radios as a channel emulator. So you could bring in multiple different types of characteristics of the channel and ensure that as people are working, change the channel characteristics to see how those interoperabilities and how those communications work. So you could see the really complex architecture of the same, and what was used is very simple. They were high-end, off-the-shelf GPUs that were running really high-end computations, sending it to the software-defined radio, which was implementing some of those coefficients onto the FPGA that's there on board, and deploying out or sending out the RF signals, which could be connected to those transmitters and receivers to see how the whole Colosseum is operating in the difficult challenges that have been put onto it. So it's a really complex system. I just wanted to show you some pictures of it. You could see some of these high-end computing platforms. You have the USRPs, which are actually the software-defined radios which are connected to it, and all of that gets in to individual devices which access UEs that can communicate from the transmitter to receiver to see how the whole thing works. So that's the really complex testbed that we worked with DARPA to establish so that people can run this competition. It was done in a very, very short period of time, which was really critical for that success. The next piece, as we spoke about multiple different challenges with prototyping such 5G systems, I move on to the test side of things. As we get into MIMO and really high bandwidth, high frequency range, it is very critical to have test systems which can drive and be able to test at high speeds and high test costs. Just like how 5G is a revolution, I think the approach to be able to test 5G is also going to be very, very different compared to what we've seen in the past. And that's where, NI as a company, we bring in, again, the similar approach of being able to prototype onto the testing side of things. Just take, for example, an antenna. From an omnidirectional or a, two antenna system, we're moving into, the NR standard talks about 64 beams. Now, how do we, as a test system builder, address 64 beams? That's the challenge that we will have. And similarly, there are going to be multiple other things that are associated with these high throughput communications. There could be things like, if you take the automotive world, there's going to be V2X communication which is going to happen in motion. So how do you bring in the Doppler along with being able to do the MIMO testing that you have to do? So just expanding on the antenna, each and every beam is going to be very unique, and each of these beams are going to drive power in each of these directions to ensure that the power is conserved when it comes to sending that data to the respective end device. And so being able to test and have that coverage as you build these devices is going to be very critical, and that's where as an organization we are trying to put our efforts in being able to scale from where we are in terms of the time it takes to test and the coverage that you would need for being able to test these newer generation systems. From a single antenna to probably a 6x6 or whatever MIMO is going to be used, there's going to be a very significant time increase that's going to come in. So time increase means cost of test is going to be higher. So the cost of test being higher means the cost of the product is going to be more, which comes in the way of being able to produce those boards at lower cost and be able to provide it to all of the users. And that's where we called out all of these different challenges with regard to how do we go about addressing each of these challenges associated with some of these devices that are coming out. It could be in terms of having a flexible RF/IF and baseband to make sure we have a good spread of test. Being able to time synchronize the MIMO systems and be able to understand the antenna characteristics, and also onboard signal processing, which enables you to decode and see how the whole spectrum is efficiently used. So those kind of things have been put together. And what we again propose for this is a similar approach like we had in the prototyping world, a software-defined modular approach. We want to scale that up for test systems so that using the exact same approach where you have IOs which can be quickly reconfigured, onboard processing with a processor, sort of heterogeneous computing system, be able to provide the complete end-to-end test coverage for these upcoming 5G devices. I'll just take a simple use case of a V2X. If you look at the increasingly connected world of cars, people are talking about cars being connected and being able to navigate on their own. Now, that would mean they have to talk to multiple different nodes at any given point in time. And being able to also communicate between each other is kind of going to be key. Now, how do you bring in all of these complexity to ensure that there is reliable communication and on-time communication to these devices? The approach that we've been able to take, we've been able to show some really good success. We actually collaborated with Shanghai University, and we've been able to establish a test bed which measures some of these latency and which enables us to quickly do some of these tests and see how the whole thing is working. At a high level, the architecture looks like a software-defined platform which talks to the phased array, the radar, the V2X module, the camera, and make sure the entire test setup can work together seamlessly. And this is a scalable approach, so as newer products come in, you don't have to change the test architecture. You quickly change the unit under test and you can quickly see large leverage in terms of being able to test some of these newer generation systems. So that's the approach that we are talking about. And before I close, I'll just show you one more video of how we work with Nokia to be able to establish that really high-speed connectivity, and then I'll probably with a couple
Every industry will be using 5G, And especially, we are seeing the huge applications of Internet of Things, starting from e-health, e-commerce, automation, manufacturing, agriculture, car industries.
So Nokia is forecasting 10,000x increase in capacity demand by 2025 or later.
So the industry has already adopted Nokia's view that 5G is about connecting people. So the industry and the requirements are already set based on Nokia's view. Nokia has been leading the pack by proposing new proof of concept system. 3 years back, we were looking for partners to implement this Nokia's vision. We wanted to be ahead of the industry, and we were looking for quick prototyping platform. So we looked at all the players and thought NI's platform gave us the right perspective where we can implement our vision.
With the National Instruments equipment, it provides a visual programming environment that lets us program FPGAs that can work at very low latency. It provides a software-definable radio where we can actually prototype our new radio much quicker than perhaps building it from parts on our own, and lets us get the system out into the field that much quicker. Using National Instruments software-defined radio platform, I think we're able to save a year's time instead of building the baseband components from scratch.
And that's why Nokia and NI were the first to prove this concept in the field. I think the sky is the limit. So the possibilities are huge. There will be applications which we can't conceive today, but it will be a connected world with all the industry connected to this 5G.
I think extending on to that, with the new radio standard coming out, we're working with Samsung where we are building the base station and we are establishing a node on the software-defined radio and seeing the interoperability. So that's something that we are working on, sort of establishing some test beds to help customers validate what they are trying to build. And I think that kind of brings me to the close where I would say if you're trying to put together some really niche algorithms and try them out, I think we'd be of some help to you. So reach out to us, and here are some demos that we have at our NI stall. And we also have a session getting into the details of the new radio standard and how NI is playing a role in being able to prototype and test those things. So I wish you a great success with this conference, and looking forward to working with all of you. Thank you so much.
Thank you, Satish. His talk was about reconfigurability. In fact, on the fly, he reconfigured the talk to finish exactly on the tick, and that's we are very thankful for him for maintaining the time. So let's give him a big applause for that. And we have time for just say 2 quick questions, if you have any. 2 quick questions.
I have a comment. I think this is a great presentation and fantastic work that NI is doing with various universities. I just like to mention to the audience here, we have a 5G test bed. We get close to about 60 to 70 bits per second using approximately 64 antennas. So this is all using Tejas equipment. I think Satish is well aware of it, because in fact Kiran Kuchi is not here. He is currently in Barcelona when I saw your slide. Maybe he is watching your demo out there.
So, Mobile World Congress.
Mobile World Congress,
That's
yeah.
awesome.
Yeah, I think Satish was there last year, even I was there, but this year I guess both of us decided not to go. Okay. So that just shares this information that, even in India, I think we are doing, I would say, comparable work, and we are almost at the state of art. Just that I was telling Mr. Shivshelam, that we are pretty bad at marketing. We should learn from the industry.
I don't think it is an industry, but I think working with Dr. Kiran and some of the people here, we've seen some tremendous things that they are doing.
Like Satish has been collaborating very heavily with Kiran.
Okay.
I have one
Sure.
question.
Yes.
You were telling about vehicle controls and things like
Yes,
that, and
yes.
you had mentioned it in a particular, going on the same path. These systems are already there in communication-based train control. You have this thing. I mean, for the first ever test conducted on the metro, the railway commissioner told that you sit in the train and I will test the train with you on the train.
Absolutely.
And the train stopped.
Yeah, I think the challenge.
So I want to know what is the new thing which is happening.
Sure, that's a very valid and relevant question. I think the rail, if you look at it, because of the constrained movement of it, whereby it moves on the rails, the challenges associated with variable factors is limited. I think ma'am spoke about the traffic in Bangalore. Now imagine an autonomous driving car in Bangalore. Right? The challenges associated with that is completely different, and it's a very big scale. There, the vehicle that can come towards it is probably another train. Here it could be a cycle guy, or it could be me crossing the road, right? So safety standards and safety requirements are a lot higher, right? And the time you get to react is also much lower. So those are some of the challenges with which they work and operate.
But when they are prescribing such a thing, they will make the car also move like a train only, one after another. So they will introduce those certain, they will make it more certain. I mean, you are certainly not going to have a person crossing the road at that time. They will always make it ensure that somebody does not cross.
Yeah, I think that is possible in some of the developed economies, which is where they are doing some of these trials. But taking it to the next level, making it mass adopted, people are talking about newer businesses where, for instance, Uber could have a fleet that runs like this, right? And if they want to do that in India, the challenge is completely of a different magnitude. And those are the areas that probably they are working on.
Just kind of a question with respect to that. They say the challenge is more in the Western world than the Indian world. Because in the Indian world, cars don't move beyond 30 kilometers. There is 120 kilometers if you're zipping, the time to react is so short that there is actually genuine questions with respect to the latencies that 5G or any other system provides to react to in such a short span of time. In India, anyway, you're going at 30, and you cannot even maneuver because there is another guy on the right side. You're stuck in a lane.
So it becomes a lane.
It becomes a lane.
Just as a counterpoint, ORR allows you to go much faster. Outer ring road, outer ring, because we easily 100 kilometers plus. You must have all zeros ordered when coming here.
We did, yeah. All right. Thank you so much, sir. Appreciate your questions.
Okay, thank you very much, Satish. I didn't read it in beginning because there was no time. He has given us some time to. So let me just read this. Satish is a strong believer of do engineering, and he has worked with faculty in designing course curriculums for teaching engineering subjects, including communication system design, control systems, signal processing, freshman course and building systems using graphical system design, etc. This kind of partly answers the question that was raised yesterday: what is academic research and industrial research? What's common to that? And so I hope your questions are somewhat answered in it. So one quick announcement that we have post-lunch session starting at 2:50. Okay. 2:15. Okay. Thank you very much. Perhaps I'll request Mr. Desai to hand over a moment or two, Satish.